transfer. We have seen that heat is energy transfer from one system to another or from one part of a system to another part arising due to temperature difference. There are three distinct modes of heat transfer. First, conduction, second, convection, and third, radiation. Now we will discuss on the three ways of heat transfer. Conduction. Conduction is the mechanism of transfer of heat between two adjacent parts of a body because of their temperature difference. Suppose we are holding one end of a metallic rod and other end is put in a flame. Soon the rod will so hot that you cannot even hold it by your bare hands. Here, heat transfer takes place by conduction from the hot end of the rod through its different parts to the other end. Gases are poor thermal conductors, while liquids have conductivities intermediate between solids and gases. Heat conduction may be described quantitatively as the time rate of heat flow in a material for a given temperature difference. Consider one end in contact with thermal reservoirs maintained at temperature Tc and other end at temperature Td. Here, we assume that no heat is exchanged between the system and the surroundings. After some time, a steady state is the reservoir at C supplies heat at a constant rate which transfers through the bar and is given out at the same rate to the reservoir at D. Experimentally, in steady state, the rate of flow of heat H is proportional to the temperature difference Tc minus Td and the area of cross-section A and is inversely proportional to the length L and is given as H equals to KATC minus Td by L, where K is the constant of proportionality and is called the thermal conductivity of the material. More is the K, more rapidly will the heat conduct. The SI unit of K is Joule per meter Kelvin second or W per meter Kelvin. You can see the thermal conductivities of various substances. You might have noticed that some cooking pots have copper coating on the bottom. Being a good conductor of heat, copper promotes the distribution of heat over the bottom of a pot for uniform cooking. Plastic foams, on the other hand, are good insulators, mainly because they contain air gaps. You might have noticed that houses made of concrete roofs get very hot during summer days. This is because thermal conductivity of concrete is very small. Therefore, people usually prefer to give a layer of earth or foam insulation on the ceiling so that heat transfer is prohibited and keeps the room cooler. Convection. Convection is a mode of heat transfer by actual motion of matter. It is possible only in fluids. When a fluid is heated from below, the hot parts expands and therefore becomes less dense. Because of buoyancy, it rises and the upper colder part replaces it. This again gets heated, rises up and is replaced by the colder part of the fluid. The process goes on. Convection involves bulk transport of different parts of the fluid. In forced convection, material is forced to move by a pump or by some other physical means. The common examples of forced convection systems are forced minus air heating system in home, the human circulatory system, and the cooling system of an automobile engine. In the human body, the heart acts as the pump that circulates blood through different parts of the body, transferring heat by forced convection and maintaining it at a uniform temperature. Natural convection. During the day, the ground heats up more quickly than large bodies of water do. This occurs both because the water has a greater specific heat and because mixing currents disperse the absorbed heat throughout the great volume of water. The air in contact with the warm ground is heated by conduction. It expands, becoming less dense than the surrounding cooler air. As a result, the warm air rises, air currents and other air moves winds to fill the space minus creating a sea breeze near a large body of water. Cooler air descends and a thermal convection cycle is set up, which transfers heat away from the land. At night, the ground loses its heat more quickly and the water surface is warmer than the land. As a result, the cycle is reversed. The equatorial and polar region of the earth receive unequal solar heat. Air at the earth's surface near the equator is hot, while the air in the upper atmosphere of the poles is cool. In the absence of any other factor, a convection current would be set up, with the air at the equatorial surface rising and moving out towards the poles, descending and streaming in towards the equator. Blowing in from north minus east towards the equator, the so-called are the trade wind. Thus, the air descends not at the poles but at 30° north latitude and returns to the equator. This is called trade wind. Radiation. Conduction and convection require some material as a transport medium. The third mechanism for heat transfer which needs no medium is called radiation. And the energy radiated by electromagnetic waves is called radiant energy. This is how heat is transferred to the earth from the sun through empty space. All bodies emit radiant energy, whether they are solid, liquid or gaseous. The electromagnetic radiation emitted by a body by virtue of its temperature, like the radiation by a red-hot iron or light from a filament lamp, is called thermal radiation. When this thermal radiation falls on other bodies, it is partially reflected and partially absorbed, and the amount of heat that a body can absorb by radiation depends on the color of the body. Black bodies absorb and emit radiant energy better than bodies of lighter colors. This fact finds many applications in our daily life. We wear white or light colored clothes in summer so that they absorb the least heat from the sun. The bottoms of the utensils for cooking food are blackened so that they absorb maximum heat from the fire. Similarly, thermos bottle is a device to minimize heat transfer between the contents of the bottle and outside. It consists of a double minus walled glass vessel with the inner and outer walls coated with silver for internal reflection.